Okay, page 2 of review 5.7. Graphically, a function and its inverse are reflections over the line y equal x. Remember, whenever we draw something, the line y equal x looks like this. So if you've got functions, they are symmetrical on either side of that line. Remember, we tilted our head to the right and saw the symmetry. Next, I'm giving you the definition of a relationship and asking you for certain things. So n has these points. Evaluate, let's start with this one, n of -2. So I look at the -2 right here for the x value. If I were to plug in a -2 in for a -2 into n, what would I get? The answer is 8. That's what this means. When you plug a -2 in, you're going to get 8 as your answer. Now the inverse, what happens when you plug a -2 in the inverse? Okay, so if you look at it, so in the inverse, let's write down what the inverse is so you don't get confused. The inverse is going to be what points? So I'm going to have -2, 3. I'm flipping everything around. 8, -2, and 3, 4, and 1, 8. So I took each of those points. 3, -2 became -2, 3, -2, 8 became 8, -2, 4, 3 became 3, 4, 1, 8 became 8, 1. So n inverse of -2 is going to be 3. Because when you plug in the inverse of -2, you're going to get a 3. Another way of looking at it is the inverse, you're going to be, remember, it changes the role of x and y. So if you're looking for this -2, it's getting plugged into the y value. So n inverse of -2 is 3. Use composition of functions to determine if these two functions are inverses of each other. So this is the big problem. I've got two things I need to show. So I need to show that f composition g is equal to x, and then I need to show that g composition f equal x. If I can show those two things, f and g are inverses of each other. So let's first find f composition g. That's f of g of x. So the way I always do that, let's write f of x. So f of x is 3x plus 4. And then I'm going to write that with parentheses. F equals 3 parentheses plus 4. Now what I need to substitute in is g. That is x minus 4 divided by 3. X minus 4 divided by 3. And now I'm going to need to simplify what you see here. So the 3 over 3, so this is going to be, so that you see it, that's 3 over 3, x minus 4 plus 4. This is just 1. So this is x minus 4 plus 4. That equals x. Okay. I'm halfway there. I have shown that f composition g is equal to x. Now I need to show that g composition f is equal to x. So g composition f is g of f of x. So the way I do this, g of x is x minus 4 over 3. Let's write it with just parentheses. Now I'm going to plug f into there, so I need to plug in g of f. So f is 3x plus 4. That's a little bit hard to read. See if I can make that a little bit better. So 3x plus 4. Okay, so to simplify this, I'm going to have 3x plus 4 minus 4 over 3. Well, the 4's go away, This is 3x over 3, which is x. Okay, so I can say since F composition G equal G composition F equal X. So therefore, I've proven that F and F and G are inverses of each other. So that's probably the longest kind of problem we have with the most of algebra that is involved, but you're doing compositions. So you have to find two compositions and prove that they equal X to make that a true statement of proving the inverse. Let's look at the next one here. Finding the inverse. So the way we always found the inverse, first thing I do is write this as y equal the cube root of 2x minus 1. Then what we're going to do is we're going to switch the role of x and y. So if I switch the role of x and y, all I did was switch the role of x and y, and now what I want to do is solve for y. So I need to solve for y. So in order to solve this for y, I've got cube roots. So what I'm going to need to do, I'm going to need to cube both sides of that equation. So on the left, I get x cubed. And then on the right, when I cube the cube root, I get 2y minus 1. I'm going to add that 1 to both sides, so x cubed plus 1 equal 2y. Now I need to divide everything by 2. So y is equal to x cubed plus 1 over 2. So let's go back and write it in inverse notation. The inverse of m is x cubed plus 1, all of that, over 2. Let's look at the next one. Let's find the inverse here. So the first step is to write it y equal 8 divided by 9 minus x. The next thing I do is switch the role of x and y. So x and y. So I get x is equal to 8 over 9 minus y. Now I need to solve this for y. If I multiply both sides by 9 minus y, I get x times 9 minus y is equal to 8. Now if I divide both sides by x, I get 9 minus y equal 8 over x. I really want to solve for y, so I'm just going to add y to both sides, and I get 9. Back up. So now I get 9 equal 8 over x plus y. So minus 8 over x on both sides. And I get y is equal to 9 minus 8 over x. So my inverse is m inverse of x is 9 minus 8 over x. So there's a lot of algebra involved in manipulating. So solving for x, solving for y, and good decisions on both sides of the equation to make that happen. Okay, to wrap this section up, some questions here. I've got a function that is p, but I'm asking you questions about p inverse. So you could graph p inverse and answer those questions is one choice, or you can just answer from here. The domain of p inverse, that's the same as the range of p. The range of p inverse is the same as the domain of p. An x-intercept on p inverse, remember x and y switch role, that's the same as the y-intercept of p. So to answer the domain of p inverse, that's the same as the range of p. I've got p drawn over here, So the range of p, I don't get y values until I get to 0. So that is 0 to infinity. The range of p inverse is the same as the domain of p. So if I look at this graph to find its domain, I don't get y values until -9. So -9 to infinity. The x-intercept of p, that's going to be the same as the x-intercept of p inverse is the same as the y-intercept of p. So the y-intercept of p, you see right there, is the point 0, 3. And, excuse me, wait, back up. Those change roles. Let me back up. So it's going to be, if I look at the y-intercept is 0, 3. So the y-intercept is 0, 3. But when I graph that on my inverse, it's going to be roll switch 3, 0. Now, another way to do this is simply graph the inverse and answer those questions. So if I look at it, it looks like I've got -9, 0. So 0, -9 has to be on my graph. It looks like -5, 2. So 2, -5 has to be on my graph. 0, 3. So 3, 0 has to be on my graph. And then it looks like 7, 4. So 4, 7 has to be on my graph. So you can see what this graph is doing is something like this, okay? Now I could just answer those same questions to the left about the red graph, and I'd be right, because the red graph is now, that's P inverse of X. So its domain is 0 to infinity. We've got that. Its range is -9 to infinity. We've got that. Its x-intercept, where does it cross the x-axis? It crosses the x-axis right there at 3, 0. Okay? That is it for the review.